Good evening, students, and welcome back. We're going to go over the guided notes for lesson 2.1, however you want to say it. Angles and congruence. We've got three different benchmarks for this one. GR 1.6, I can solve problems using congruence and or similarity. We're just going to talk congruence today. I can identify the steps to constructing a copy of an angle. That's GR 5.1. And we are going to look at that, but a lot of that's going to happen in class. Unfortunately, I don't have, excuse me, I don't have my my compass and protractor with me, so we're going to skip that. All right, from GR 5.2, I can identify the steps to constructing a bisector of an angle. So again, we'll talk a little bit about the construction stuff. I do have a video of another teacher. He's really good at these. I'm gonna post the links to his videos on like constructing a line that's congruent and all this stuff we're talking about, just so you guys can get a better a better or another, I guess, perspective, somebody else talking about it. So more to come on that. Okay, sorry to keep rambling. Let me make sure our video is rolling. Yes, it is. Okay. All right, so we got some vocabulary, starting a new module, so that should be expected. We would have already worked the bell ringer for today, so now we're going to get on into the key vocabulary. Start with array. Array is a part of a line that starts with an endpoint but extends indefinitely in one direction. And at one point this week, and really since the beginning, between the Alex knowledge check and some different things we've kind of been doing in class that may not have been on the videos or in the notes here. But yeah, so array has one endpoint, and then it extends on the other way. So it has the arrow, and it's usually identified by, it'll get the endpoint, which we'll say B, and then we'll say it has C here. So this would be called ray BC. This is when it matters. We read toward the arrow. So BC. If the arrow was this way, it would be CB. All right, so opposite rays. Opposite rays are collinear rays with a common endpoint. So I'm gonna, let's see, I like to use different colors. And I'm actually doing this video before we have the lesson. This is the first one of the year that I am doing first, so it'll be a little rocky. The first few videos happened after we had done it in class, so the good part is you guys in class will get a better version. Unfortunately, when you come back and watch the video, you're going to be like, but if you have any questions, you always, you can talk to me. So let's do this. All right, so opposite rays. So our opposite rays would be BA and BC. See, BA goes this way, BC goes that way. It's like a straight line. Yes, that's what it is. All right, an angle, a pair of rays that have a common endpoint. So let's kind of limit it on my colors here too. I bought some new colors, but I left them at school. So let's say this ray goes this way and this ray goes that way. So yeah, it's an angle. And you guys have seen angles. I know at least in the 6th grade, but probably before that. My girls are in the 3rd grade. I will be asking. Okay. All right, so straight angle. And this is, what did I say? I put on here AKA. It's a straight line. All right. And I know I'm going over my line here, but a straight line. So that's, let me do this. Hold on. You know me and the colors. This whole thing is worth 180 degrees. So an angle that measures 180 is a straight angle, but it's also a straight line. Okay. very important as we study this year. This is one of those things that we're going to use a lot. So keep that in mind. All right, vertex, common endpoint of two opposite rays. So we'll speed it up a little bit. So if we got opposite rays, opposite doesn't necessarily mean completely opposite like here. It can mean just opposite directions. So here, these two rays, their opposite, or their common endpoint is going to be K. Say K goes this way. I didn't do all the other to write that stuff, but you guys get the point. K is the common endpoint for these two opposite rays. All right, adjacent angles. Let me see where I can write this, but give me just a moment. Hold on. Lost some of my stuff. Okay. Two angles that lie on the same plane, which, like I told you guys, we'll talk about planes beginning of Module 1. We'll talk about them later when they intersect, but for the most part, everything's on the same plane. Anyway, so they lie on the same plane, have a common vertex, common side, but no common interior endpoints. All right, so how did we... Let's see, give me just a moment. So I'm going to draw this thing like this. Sorry, you guys. Drawing is terrible, and I know that should be like some sort of prerequisite for a geometry teacher. You should be able to draw, but I got through that one. Whew. All right, so two angles that lie on the same plane have a common vertex. So their common vertex, we're going to call it P. So P is a common vertex for this angle and this angle, okay? They have a common vertex, common side. This is your common side here. But they have no interior points and interior. So I'm going to do these. So the interior for this left side is going to be green. So you notice it goes here to here. And then the interior for the other side is going to be blue. And again, so see, they don't share any interior points. If we had a point over here, it would be in this angle. If we had a point over here, it'd be in this angle. In the middle, that's not an interior angle. It has to be interior of this vertex. Exterior, of course, is on the outside. So hope you guys are following what I'm saying there. All right, next word, linear pair. So adjacent angles. Let me also. I know that's probably hard to read. Adjacent also means next to. So just keep that in mind. All right, so linear pair. Let's see, all right, so linear pair, see a straight line like up here, but a linear pair is a measurable part of a line that consists of two endpoints and all, what? Wait a minute. Okay, all right, so this is the definition of a line segment. So scratch that one. Of course, I already printed this. A linear pair, basically, these are two angles that make a straight line. Or, see, aka straight line, aka straight angle, 180 degrees. So don't confuse that later when we talk about supplementary. Supplementary equals 180. However, linear pair, so see how this is a straight line. This is a ray that comes off of these straight lines. But this guy, we're going to say A, and this guy, we're going to say B. So A and B are going to equal 180 degrees. They also make a straight angle, just like up here. So I'm going to push that on you guys a lot. Very important. Very important. That one and this one. Matter of fact, I don't have a highlighter, but I do have a yellow colored pencil, and these guys are very important. If I could, yeah, very important, very important, very important. All right, so this next one, vertical angles. So these are two non-adjacent congruent angles formed by two intersecting lines. So non-adjacent meaning they're not next to one another. and they're formed by two intersecting lines. So this guy and this guy, line. All right, so I see we got this above here. I'm going to try to make this. So non-adjacent. So this and this, and the adjacent ones, you see they follow the straight line. So adjacent here are a linear pair. And the non-adjacent, so the ones on top of one another and the ones next to one another, those are your congruent angles because they're non-adjacent. And this is always, always, always. So in this case, 1 and 2. You see 1 and 2 are non-adjacent. They're on top of one another. Those are congruent. And in here, 3 and 4, those are next to each other. Across from each other, not next to one another. So in this case, 1 and 2 would be congruent, 3 and 4 would be congruent, but notice 1 and 3 are on a straight line, so they are a linear pair. So 1 and 3 would equal 180, 2 and 4 would do the same thing. I'm kind of dual teaching here, I want you guys to know about the non-adjacent sides being congruent, but I want you to go ahead and also see that your adjacent, when you have two intersecting lines, that forms a linear pair. If you guys get that now, geometry is going to be super sweet, bro. So let's go in here. So speaking of stuff, and I've had one person that in now my 2 years of doing videos, thank you. Well, I won't say your name because, I don't know rules or whatever, but you know who you are, that you found the extra credit in one of the previous videos. So I'm going to say here now, for those that are listening, you guys know I graduated from Alabama. I'm doing this video the day after they lost to Florida State. Not looking for any pity. Just saying, if you say, hey, I'm sorry for your loss, I will give you 5 points for this week on the assignments portion of what we do. Our stuff's broken into assignments, assessments, and exit tickets. So this one will be on the assignment portion. There will be something later about on the test portion, but it'll be something more math than football. It'll actually be some useful information. Okay, continue on. Example number 1. So I'm going to work example 1. You guys are going to do example 1 check. You're going to do 2. You're going to do the check, flip it over, and so on and so forth. Okay, so example 1. Name all angles that have D as a vertex. All right, so I don't know where my purple, where the purple went, but we'll do it this way. We'll say orange. So name all that have D as the vertex. So D is right here. I'm just going to do D this way. Oh, geez. Okay, hold on. Hello. Broski. Okay. All right, so we're looking here. All the angles that have D as the vertex, that's really just going to be 6. So we're going to say angle 6, and let's just make sure. There's also, well, you could say BDC, and you could do that backwards. CDB. And that's pretty much all you got, because D is just the one vertex. Notice it fits here. So if you look here at 7, that's not D. D's over here. Well, I guess it is that point. Yeah, we'll ask about that. All right. B, name the sides of angle 2. So I'm just going to, so angle 2 is right here. So these are the 2 sides. And what are our 2 sides? We have AB. And we have BD. All right. Part C. Name a point in the interior of FDE. I'm going to do it like this, FDE. So the interior of an angle, so FDE. So that's this angle. So the interior is inside this angle. So I'm going to color it in. And there's only one point, and you see, and it's A. These points are all part of that, F, D, and E. B is on this. It's not inside. It's on the line. So the answer is A. All right, so now name all the points that are exterior FDE. So if this is the interior, this is the exterior. And I kind of just color it in a little so you guys can see. You know, I want you to understand what we're dealing with. If it, you know, takes a little more time, so be it. It's like I told you guys, if, you know, if we get this in 3 problems, great. If we get it in 10 problems, that's fine too. We're going to do what we need to do. So, oops, we're rolling. All right, so what points are all in the exterior? So the blue here. Remember, it's not the line here, so it's everything else. So B's on the line. Don't let that confuse you. D's on the line. E. So anything out here. So you would look at C. You would look at H. And G. Okay? Easy peasy. All right, so for the check, name the vertex of 4. So 4, I'm just going to draw these out here. Just so vertex 4. Vertex 4. All the names for 3. 3 is right here. And another name for X, Y, U. So X, Y, whoops, Y, U. All right, so there you go. We're going to scooch down. Look at example 2 real quick. All right, it says in the figure, BA, so BA, ray BA, and ray BC are opposite rays, okay? BD bisects angle ABE. And then it gives us some measurements. So let's look at the first sentence here. So these are opposite rays, okay? So that means everything here is 180 degrees. All right, everybody with me? Right. Let's just do this. Let's just say that because those are opposite rays, I'll just do this and this. That equals 180, okay? Just, you know, these are good things to have because geometry, and I've tried to mention this, and, you know, I never know from class to class how many times I say something or if I say it at all. So, excuse me. So I always like to include it on the video as well, but the geometry is a lot of trick questions, very puzzle-like. You guys have asked about the chessboard in the room. I'm going to end up trying to start a chess club if any of you guys are interested. Geometry is very chess-like. You really have to think big picture. You can't just think little stuff. So I'm trying to give you guys things to think about as we go. So if they're opposite rays, everything in between them is 180. All right, and they say that BD bisects ADE. So BD bisects ADE. So now, so what have we said in class about the word bisect? I hope somebody's yelling at their phone or whatever they're watching. Yeah, bisect means 2 equal pieces. All right, so that means that these two are congruent, this side and this side. I know I have that there, so I'm going to do this in pencil, and I'll kind of make it a little different. But that means that ABD is congruent to DBE. That's just something we need to know. All right, so now we've kind of dissected what they wrote. Now let's see what they tell us here. So the measure of ABD, so ABD here, is 4x plus 14 degrees. So 4x plus 14. Waiting on it to catch up. All right, so that means, come on. So that means this angle is this measure. What is it? Okay. Hang on 1 second, guys. We're going to pause right there. I apologize. Okay, sorry about that. Bedtime around here. All right, so they tell us that ABD is 4x plus 14, and that DBE, so this side, is 8x minus 32. All right, so remember, these bisect and these are congruent. We're just going to put these two equal to one another, solve for x, but they want us to find ADB. So let's say 4x. Let's actually give me just a second. Do I have a pen? Or am I just going to... Yeah, here we go. All right, yeah, so let's do it this way. So 4x plus 14. So they're congruent, so they're equal. That's 8x minus 32. All right, so 4 is smaller than 8, so I'm going to subtract the 4 from both sides. Remember, we're always trying to get x by itself. I suggest subtracting the smaller from the bigger because it leaves you with a positive, not a negative number, but sometimes you have to do it. All right, so 4x minus 4x is 0, so it cancels out. 14, it just comes down. Equals, all right, 8x minus 4x is 4x. And then that minus 32 comes down. All right, so we still want the x by itself. So we're going to add 32 because it's subtracted. Add 32. Negative 32 and positive 32 cancel out. 4x, he's coming along for the ride. We didn't touch him. There's the equals. All right, over here, 14 plus 32. That's going to be a 6 here, a 4 there. So 4x equals 46 divided by 4. Hold on 1 second. Make sure. Yeah, that's 40. Okay, whatever. That's going to be... Oh, 12. Okay, never mind. All right, so 46 divided by 4 is going to mean x equals 12. Now remember, they wanted ADB, and ADB was 8x. So I'm sorry, DBE. Excuse me. DBE, the measure of DBE equals 8x plus 30. I'm sorry, minus 32. So we know x is 12. So 8 times 12 minus 32. All right, 8 times 12 is 96. 96 minus 32 gives us 64. So DBE is 64 degrees. And that's what they asked for. All right, so over here, it tells you these guys are opposite rays, KM, KJ. It says here, bisects. So you know what that means. So if it bisects JKL, that means this side and this side are congruent. So you know what to do with that. All right, flipping over. Page number 2. Example 3 at the top. Let's see what we got here. All right, so how many pairs of adjacent angles do we see in this figure? List 2 pair. All right, I want to bring something back to your attention. The word adjacent. That also means next to. Okay? So next to would be like this and this would be next to each other. I'm going to try to do these with colors, but it's kind of difficult because everything's going to have two. So like this guy and this guy would be next to each other. This guy and this guy would be next to each other. But you could also say, I'll do it, this guy and both of these guys would be, and then the same thing there. So it's saying list 2 pair. We're going to say ABE. ABE, and then we'll go with this guy down here, DBA. All right, so list or identify two vertical angles. So remember, vertical angles are on top of each other or next to each other. So that would be like 1, 2, and then 3, 4. So where this one here says 138, this other side, they're congruent, it would be 138. Now, what are these other two? Okay, glad you asked. Notice these make a straight line. So this guy is 180, a whole line, minus 138. So 180, that's this whole thing, minus 138, that's this over here. We subtract them and we get 42. So this one's 42 degrees and down here's 42 degrees. So how many linear pairs do you see? We see 2, 1 and 2, and 3 and 4. List each pair, so we'll call them by their right name. So A, B, E. And here the down, so it'd be D, B, C. All right, so that's the first one. The second one, A, B, D, right? Lord, I can't see. And then the other side is E, B, C. Okay? Hopefully that makes sense. If you have any questions, just let me know. All right, it's saying find the measure of EBC. Well, we've already done that up here. I thought ahead. See, I've done this a minute, so I want you guys to learn and follow me. And hopefully you pick up on these little things. Oh, I see vertical angles. I'm just going to go ahead and label all their measures because guess what? I'm sure it's going to ask it to me in a minute. All right, so EBC. EBC. Well, it's vertical to this one, so it's 138. All right, and then what's ABE? So ABE. So that was the other side to this. We figured out that these two are a vertical pair. So this was 180 minus 138, and it gave us 42. And if you add 138 and 42 together, you will get, drum roll please, 180, because they are a vertical pair. All right, construction part here. I'm going to talk about it. I'm not going to do it because I don't have the tools. But again, I'm going to post videos. So it says copy given angle B. Use a straight edge to draw a ray on paper. Label it G. Place a thumbtack at the vertex of B and draw a large arch that intersects both sides of angle B. Let the points of A and C intersect. Oh boy. All right, yeah. We do have a a little foldable. We're going to do, this is 2-1. I've actually, with everything we have going on, I'm not giving you the foldable till 2-2. But we have some stuff there that we'll work on. And again, I will post that video. So this stuff, it gets into being a lot. I'm glad that we have the technology we have, that we don't have to do geometry the old school way as much. It's a lot sometimes. All right, so let's go down here. Number 2, student wants to copy an angle using a thumbtack string and a pencil. What is the main geographic principle being applied to this method? Let's see what our choices are. So angles can only be copied with a protractor. I don't think that's true. I think if you use the string and all this other stuff, you can measure it right. All right, B. Well, this is really weird. What I have on my paper does not match this whatsoever. I have the compass helps measure and transfer the angle's arc angle and maintains congruency. What does this say? The string helps measure, and yeah, okay, that's right. So it would be the same thing, yeah. It's just, it was talking about the other, and it shouldn't have been. All right, and the thumbtack is used to bisect the angle. So yes, you use the thumbtack to bisect it. This message is only useful for straight angles, straight lines, not angles. That's not true. All right, so the practice. If you did not get one, please see me, but I do have the worksheet for the 2.1 practice. We are going to do numbers 1 through 17, And for our home learning for this entire week, so we're doing 5 topics on Alex, but that's the whole week. You 11th and 12th graders, if you are there Thursday during testing, you'll be able to do those 5 topics while you sit somewhere. Just make use of your time. All right, let's go down here just a little. All right, summary. When bisecting an angle, using tracing paper, you should fold the paper until the 2 blanks of the angle overlap. And it's going to be sides, even though we didn't do that, but it just... angle, that's what they have. They have 2 sides. Number 2, in geometry class, Tammy indicates all adjacent angles are linear pairs. Is Tammy correct? And yeah, that one was different, but this is going to be no. And the reason it's no, so adjacent means, next to. And where she would be right would be like here. This is a linear pair. These are next to each other. This is a linear pair where these are adjacent angles. So this would work. But what if it was here and there's another one and this? Well, these 2 are adjacent, but they don't make the linear pair because this is a linear trio. It didn't make a full line. So that's kind of what what makes that no. I know they want you to explain. Well, that's how we explained. So survey for this. If you understood everything well, please mark it. If you are a little unsure, let me know. And if you're totally confused, also let me know. We'll try to work out something during class. I know we're a little limited on our time, and I try to work with as many of you as I can. Tutoring is also an option. I'm sorry I missed last Tuesday. This coming Tuesday, so the day after Labor Day, my kids, their school canceled their clubs, so I can't stay till 5, but I can at least stay till 3. If I have enough sign up, I might can sweet talk my mother-in-law. Tomorrow's her birthday, so I don't want to over ask, but if you guys need the tutoring, I think she would be willing to help. So just let me know. Again, this video is coming out early, so I'm saying things that are probably going to pass. But anyway, until next time, have a good night.